And now I'd like to say a couple more things about the standard deviation and the standard error of the mean and how they are the same or different. And you might want to use either of these to add error bars onto a graph, and I'll explain in a minute what those error bars mean, or quote them when reporting your results. But the most important thing is think carefully about which one you want to use. And make it clear which one you're quoting, which one you are using. Right, so first of all I need to talk very briefly about both of these assume a normal distribution of your sample. Normal distribution. So I'm not going to go into any of this in any great detail, but what it means is, so let's imagine we've got a population. So here's a graph showing all our different measurements that we've got from our population, and here is the mean. So so all the measurements are evenly distributed about the mean, so it's symmetrical around the mean. Distributed around the mean, and it's more likely that there are more measurements nearer the mean. Okay, so now let's just talk a little bit about the standard deviation and the standard error. Do a bit of comparing and contrasting. Right, so the standard error is kind of looking at the underlying population. So it's looking at how much the individual measurements vary in your population. Whereas, on the other hand, the standard error of the mean is looking at how much sample means vary compared to the kind of around the true population mean. Okay, so this is more looking at the experimental kind of sampling errors, if you like, and this is looking at underlying property of the population more. Alright, so then what we've got to do looking at this standard mean, based on this normal distribution, I mean. So we know that most of the measurements are going to be closer to the mean, and in fact we know that for a standard deviation, about 63% of measurements are within 1 SD of the mean, and 95% of measurements are within 2 SDs of the mean, so 2 times the standard deviation. So for instance, if the mean, let's say, is 10 and the standard deviation is 1, then 95% of the population, of the measurements in the population, will be in between 8 and 12, because that's 2 times 1, 2 standard deviations. Now, similar story for the standard error of the mean, but here 63% of sample means are within 1 SD of the population mean, and 95% of sample means are within 2 SDs of the population mean. So similar but different.